Hey everyone, who is this? What is this? And how about this? As a human, I'm guessing that you answered Einstein, an apple, and a cat. And hopefully those are pretty straightforward. But what if we asked a computer those same things? Could it identify them? Well, we know that obviously it can because we know that image recognition is a thing. But how? That's what we're going to talk about in this video. You may have heard that a neural network mimics the human brain. Our brain is made of neurons, so hence the neural network. And in computer speak, a neural network is really just an algorithm or a set of instructions that's used in deep learning. They do things like image recognition, object detection, fraud detection, and they're even used in self-driving cars. But let's walk through a simple example of how they work. If I gave you this image, you could probably identify pretty quickly that it's a leopard. But let's figure out why it's so easy for you to identify and how the human brain looks at this. If you think back to when you were a kid, the first time you saw a leopard, or probably a picture of a leopard, at some point somebody presumably told you or you read that this is a leopard, and we call that a label. If you hear the term supervised learning, that just means that the thing that we're learning about has a label or a name attached to it. And in our case, that's a leopard. So you, as a child, would make a note to yourself, okay, the leopard has black spots, yellow eyes, rounded ears, and whiskers. Check, that's a leopard. Now at some point, you'll see another picture or another leopard that looks maybe like this. So this one also has black spots, yellow eyes, rounded ears, and whiskers. But on this one, I can see 4 legs and a long tail. I didn't see that initially. So it's a different angle, we're in a different environment, this time on dirt instead of grass, but most of the characteristics look the same, so I can conclude that yes, this is also a leopard. And on it continues, you see different pictures of leopards. This one is standing a little bit differently. You can see its teeth, big sharp teeth. But by now you've learned enough about leopards generally that you can conclude, yep, this one also looks like a leopard. So that's how the human brain works when we learn. Now let's build on this and talk about how it works in a neural network. At a very high level, it's similar. We pass something into the network, the input, we do stuff, and then there's output. So thinking about our leopards, we would pass in a photo of a leopard, we do stuff, and then at the end we're able to say, aha, that looks like a leopard. But this part here in the middle where we do stuff, that's actually where the work happens. There's a lot going on here, and it happens in what are called hidden layers. Conceptually, this is the equivalent of a child saying, okay, I see the leopard has black spots and yellow eyes and so on, so figuring all of those details out. In the neural network, maybe one layer is only concerned with the color of the spots, another with the color of eyes, one with the shape of the ears, one with whiskers, and then another with the number of legs. So each layer is focused on just one aspect of the picture, trying to find the patterns or the colors that make up these characteristics. But not all layers or characteristics are created equal. Some have more importance or more weight than others. For example, the black spots are pretty important. If you think of other animals with black spots, there aren't tons of them. There's a few dogs, the giraffe, some birds, but we're going to say that this is a fairly high weight or fairly high importance when we're figuring out what kind of an animal this is, so we'll make it 0.7. The color of eyes, yellow eyes are a little bit more common with reptiles, birds, dogs, fish, so we're going to give this a weight of 0.5, and then we would continue on with the other characteristics. We'll call it 0.4 for the ear shape, maybe 0.2 for whiskers, and a 0.1 for the number of legs, since a lot of animals have 4 legs. And it's just a total coincidence that these are in descending order. That doesn't mean anything, but we're going to figure out all of the correct weights for this leopard, so we're able to say, yes, that looks like a leopard. Check. But then maybe we pass in another image that looks like this. Our neural network goes through all the same steps using the same weights and so on, but this time it says this picture does not look like a leopard. Instead, we think this is a cheetah, which is not correct. So how do we make the neural network smarter, helping it to make accurate predictions more often? That's where training comes in. We train a neural network by providing lots and lots of labeled data. And remember, the label just says this is a leopard or this is an elephant or whatever it is that we're passing in. So we just pass in lots of those examples until it learns and has a high rate of accuracy in making predictions. So we pass in leopards in horizontal pictures and vertical pictures, leopards sleeping, in trees, standing on 4 legs, camouflaged in trees, coming straight on towards you, leopards rolling over, in the grass, in the trees, and so on. And then, do we also want to account for snow leopards and black leopards? If so, we might need to change our criteria a little bit. Their colors and spots and eyes are different, but they're still leopards. We would also need to pass in some baby leopards as well, and so on. I think you get the idea. So in the end, it has seen so many leopards that it'll be able to really say, yes, that looks like a leopard. But then in addition to all of these examples that we've passed in, we also need to adjust the weights and other parameters to get things just right. Maybe we find that we weren't giving enough weight to black spots, or we were giving too much weight to yellow eyes, that kind of a thing. So as we pass back and forth through the network, we have to adjust those parameters until the accuracy improves. But then when we're done with the training part and we're happy with how well it's making predictions on labeled data, we then save the model and we can use it to do inference. And inference just means that we're passing in a new image, things that it hasn't been trained on before, and it's able to make a prediction about them. So we pass in a new random picture of a leopard that it hasn't seen, and it can correctly identify it. Or we pass in a photo of a giraffe, and it will say, nope, that is not a leopard. So that's really the entire goal of the neural network. So that's it, a super high-level explanation of how neural networks work. If you want me to do another video that gets more into the underlying math, and maybe even how to create a neural network in code, then let me know below in the comments. Thanks so much for watching.